Yeah? Oh, I just think.
Is that what you've been in here ever since like 1? No, and then people started coming.
Yeah, I wasn't part of the convo.
Hey, can you put this next to
No.
Franklin?
This is Dr. Jason Keegan. He's going to be doing our hydrogen economy and fuel cells and microbial fuel cells talk. So I'll let him get started.
So my name is Jim Case, that's my Chinese name, and you can call me Jason, easier to remember. And I'm a postdoc research here. I'm working on the environmental technology and bioenergy production. Next time, I'm going to talk about like 30 minutes, 5 minutes, then we have a short walk to our lab. Take a look at what a real lab is. It's messy, don't expect a very clean lab there, and see what a real microbial fuel cell is. Alright, so how many of you have heard about hydrogen economy? Quite a few. What about fuel cells? Wow, looks like I should skip these two parts. Alright then, who knows about microbial fuel cells? Great. Finally, I can have something to tell you. Alright. Now we start with those energy crisis. So you all know that I don't have to spend any time like we spend. We're consuming oil, coal, natural gas. They all fossil fuel. It's just one-time thing. You stop, that's it. And the renewable energy, it's hard to control all three of them. So renewable energy, it's really small amounts. That's what we look at. Renewable, that means we can get them again and again, like agricultural operation. We get them this year, next year, we get them again. And nuclear energy is another option. Then the source of electricity in US, no matter if you believe it or not, most of electricity we use still from coal. That's not a clean resource, right? You have to burn coal and produce a lot of particles, aerosols, pollutants, and very low efficiency. More importantly, we're used up with the coal. And most energy, electricity from coal, then from 20% from nuclear. Nuclear is a clean energy resource. The main concern is the security, right? Safety. When people talk about nuclear, is always like, well, scared. Actually, it's not that bad if we can really take care of the nuclear waste. That could be a problem. And at this moment, so what we do about nuclear waste is just dig a hole in the earth, then store them forever. We don't know, maybe in the future we have a new technology to deal with that, but at current stage, we just store them for the waste. Then 7% from hydroelectric. That means we have to build a dam, right? In America, there's already a lot of dams on major rivers. That's limited resource. Only 5% from renewable energy, solar, wind, geothermal, and other sources like biomass. Solar, wind, geothermal, those are really dependent on the special character of the area. For example, in California, there's a lot of sunshine. Ideal location for the solar panel. Yeah. Now they start to build more and more solar panels. The question is why did they start early? Because they didn't worry about the energy crisis before. And the wind energy, wind power is another great resource, because in UK they have like 20% electricity from wind power. So you just build them and put in the near shore ocean, they produce electricity. Well, those about energy introduction. Now we talk about hydrogen economy. Hydrogen, we know they are the most abundant element on the Earth. So what is the second most abundant element on the Earth?
Carbon.
What was that?
Carbon.
No. Element, single one.
Oh.
What's that? Silicon is quite loud, but still not in the top 3.
Carbon.
Well, carbon is in the top 3, but not second.
So nitrogen?
Now we breathe. Yeah. Yeah. Oxygen is the second most abundant. The most one is the hydrogen. So the hydrogen is everywhere from water. And the third one is carbon. So those top 3 are the most important elements. See, the human body are most complicated system. We are made of those top 3, right? Hydrogen, oxygen, carbon. All the carbon, organic carbohydrates made of those 3 elements. So we can the hydrogen, we all know hydrogen burn with oxygen, make water. This reaction can go reverse, so water can be split into hydrogen and water. So that provides a possibility how hydrogen is produced. Please.
Is the forward or the reverse reaction spontaneous?
Not spontaneous, you have to do some work. Obviously, you understand that if the forward reaction is spontaneous, the output, the reverse one, they need some additional energy. It's not spontaneous. That's why I talk about next how we're gonna make hydrogen. Well, although we have water, we can split water into hydrogen and oxygen. Unfortunately, the most hydrogen production nowadays is still from fossil fuels. Say natural gas, coal. They made from methane gas, CH4. That's the natural gas you burn at home for cooking, and the carbon monoxide, so syngas, to make hydrogen. Most hydrogen production still goes this way. And the new technology, actually it's not, some of them are not new. Hydrogen splitting, called hydrogen electrolysis, electrolysis of water. Then you have to apply electricity to split water, H2O, into hydrogen and oxygen. So how much electricity you need? Theoretically, 1.23 volts. So 1.23 volts, if you apply the voltage higher than that one, you can actually split water. That's quite easily. If you have some power supply, 2 electrodes put into the water, you can see gas bubble. So one is oxygen, the other is hydrogen. So that's pretty simple, how hydrogen is produced. Well, that's fun for experiment, but not fun for the industry production because you have to save energy. When you apply potential, you actually apply a lot of energy. So you input a lot of energy, get hydrogen, another energy carrier, and you have to think about if you get more energy. Otherwise, the businessman won't give you money to start your company, right? You have to make profits. So people think about how to make hydrogen from water. Electrolysis is a traditional way. Apply potential, electricity. Then there is biohydrogen, produced by algae. Those microorganisms are very amazing stuff. They can make anything. We just have to really figure out, explore that well, please.
Do you think that using algae as a power source would be convenient, or would it just be, would you waste too much energy producing energy from algae for it to actually be efficient?
Well, the good thing about algae is they can convert solar energy, right? You don't have to input any additional energy. They just need sunshine and water and low-level nutrients to grow, and you can grow a bunch of algae. The one thing, energy from algae, there are two types of things. One is hydrogen. The other is a more popular term, biodiesel, right? People can make biodiesel from algae because algae has a lot of lipids, all kinds of organics. People can extract biodiesel from algae. So that's a good thing. The bad thing about algae is they're so teeny tiny. You have to collect them. When people make biodiesel, you have to collect them and filtrate, remove the water, right? All those processes consume energy. So when you produce certain amount of energy, you have to go look back at this process, how much energy you have consumed to make this amount of energy. So that's kind of complicated.
Is there a formula for biodiesel?
Yeah, there is. There's already industrialized. So people can make it at a larger scale. You mean the formula, how to...
As in, sorry, the chemical...
The empirical formula.
Yeah.
The diesel is a group of petroleum compounds. What we call the diesel group compound. It has like, I don't remember exactly, like 22 carbon to 24 or 27 carbon. It's a complicated compound. If you're interested, you can look into details. I don't remember it exactly. But it's a group of compound. Like gasoline, it's also a group of compound. It's not a single compound, gas. Right?
Would sewage water have enough algae to power it?
Well, I'm going to talk about sewage water, but sewage water won't have enough algae to grow. Sewage water, because most treatments, they're not really directly under the light, and also producing algae is not their purpose. They try to get rid of the microorganisms, try to get rid of organics. But we have another way to deal with sewage water. I'm going to talk about next. That's really I'm good at. So. All right.
I was just quickly about the algae. I know China right now has a huge problem with a lot of algae in the rivers, and the government is trying to get rid of the algae. Do you think using that enormous amount of that and transferring it to energy, so they could power like different things, would be efficient, or would it just not?
Well, because algae still is a big term for a lot of different species. There's all kinds of different algae. Certain species contains more higher content of lipid that can be extracted as biodiesel. Other species, they're still algae, but they may not economically efficient to be used for biodiesel production. So that's really depends on which algae species we're talking about. For some algae, probably it's not worth to extract bioenergy. Well, you have to just get rid of them because they produce eutrophication, right? A lot of algae, they consume oxygen, then the fish or all kinds of organisms under the water level will be dead because oxygen is depleted. So that's really depends on which algae. For biodiesel from algae, they really build up a pool, special pool to produce algae. Have a lot of sunshine, special pool, then they extract huge amount of algae because you have to industrialize that, you have to make it larger scale. So that's one thing. The other thing, yeah, we talk about biodiesel. Now we come back to the hydrogen. So algae actually can directly produce hydrogen, but it's not compared to biodiesel from algae because this is still like research level stuff. It's not there yet to make it industrial scale for the hydrogen, but it's a one pathway. We know algae can make hydrogen, or we know the bacteria can make hydrogen, biohydrogen from organics. We call fermentation. So bacteria can decompose complex organic into hydrogen and other products. So those are the pathway, the major pathway we can make hydrogen. Coming to the question, which way we're gonna really adopt the electrolysis of water has been industrialized, and the fossil fuel has been industrialized. The biological pathway still requires further research, so it's not there yet. But I would like you to know there is a possibility. Although we make hydrogen, now we know how hydrogen is made, and we now have hydrogen. What to use? Of course, to burn the hydrogen, right? To burn the hydrogen and make water again. The one device we use is fuel cell. You all know about fuel cell, so I don't have to really explain a lot. We have the hydrogen one side, the oxygen the other side. We have electrocatalyst. So hydrogen can be catalyzed, oxidized, half reaction here, and produce electrons. Oxygen is reduced by accepting electrons to make water. So this process can produce electricity. One single fuel cell can produce 1.2 volt, 1.23 volt electric potential. Remember how much electricity did I say we need to split water into hydrogen? Yeah, it's the same one. So that's thermodynamic value. They can produce maximum 1.3. You have a question?
Yeah, can you say that again?
Yeah, I mean the single fuel cell based on hydrogen and oxygen can produce a maximum open circuit potential of 1.23 volt. This is determined by the thermodynamic value of those hydrogen and oxygen, Gibbs free energy, blah blah, those like. So previously I said we need apply electricity to split water into hydrogen and oxygen. That will be the same number. So we apply at least 1.23 volt. Why did I say at least 1.23 volt? Because we cannot get 100% efficiency, right? There's all kinds of things that just consume your energy. So you have to apply, people actually apply about 1.8 volt, 2 volt to split water into hydrogen and oxygen. And I have a small example. So the fuel cell, they're pretty powerful fuel cell. Though the fuel cell, the next I'm going to talk about micro fuel cell, there are totally two different things. I shouldn't say totally two different, but they have a completely different purpose. Fuel cell is compact, small size, powerful. They produce a lot of electricity. Micro fuel cell, huge size, but their power density is not comparable to fuel cell. They produce a low power density. But since they have a huge volume, they still produce quite amount of absolute electricity. Then here's an example of fuel cell car. You may know more than me. I'm not an expert on the vehicle. So we have the fuel cell, hydrogen, tank, that's like a fuel tank. The big issue about fuel cell vehicle is hydrogen storage. Why? Because hydrogen is so light, right? Its molecular weight is 1. That means the small mass hydrogen, huge volume. You have to compress them into small volume. For vehicle, you cannot have a huge gas tank, right? It's limited. So hydrogen storage has been a really big issue for the application of a fuel cell vehicle. Well, if you are interested, you can really Google fuel cell vehicle. There are all kinds of cars available. Another thing I'm going to talk about, another new application for the fuel cell, they call regenerative fuel cell. This will be applied in outer space, for example, on the moon. On the moon, there will be like, for example, 15 days totally darkness, and another 15 days full of sunshine. When there is a sunshine, you can use a solar panel to generate electricity, right? So that's pretty simple. But what are going to do when there's complete darkness? So research come up with ideas. When there is a sunshine, they use solar panel to generate electricity, generate more electricity than what they need. So they have additional electricity. Then they apply this electricity into a fuel cell. So reverse the process to split water into hydrogen and oxygen, right? I said when we apply electricity, we can get hydrogen and oxygen. So they use the additional amount of electricity produced from solar and to generate hydrogen and oxygen. When there is no sunshine for another 15 days, they use those hydrogen and oxygen generated when there is sunshine to make electricity in fuel cell come back to produce electricity. Is that complicated? You got my idea, right? When there's sunshine, they use a solar panel to generate electricity for their use and generate additional electricity to reverse fuel cell process to make hydrogen and oxygen. Yeah, please.
Are you supposed to store, like we had a speaker earlier, so we can store the energy that is generated by the solar panel? So how would we be able to do that?
Well, that's a good question. We cannot store the energy. Then we use them to split water and make hydrogen and oxygen. So those compounds could be energy carrier, right? When there's no sunshine, we put them together again in the fuel cell, they generate electricity. I think it's still under research. Yeah, that's a quite promising idea. Depends probably when next time people are gonna step on the moon, then they can bring this technology over there. Yeah. But you have to prepare well before you really step on, right? Yeah.
So it's not fully developed yet.
No, not yet. So the most slides I'm talking about here is research idea. Yeah, that's why you come here as university, right?
Yeah.
So it's full of research idea. Otherwise, you go to company, they already have every product there. So here we talk about research idea. Now this is another application about fuel cell. Now we come to the environment, what I'm good at. So I'm talking about energy and the environment. Now you mentioned the waste in the sewage. They contain a lot of waste. What is waste? Organic. Everybody here produces waste. We dump into the sewage water, and they have to be treated before discharge into the natural water. So waste actually contains huge amount of energy. They are organic, and they're just energy source in a wrong location. That's a famous saying in the environmental engineering. And those organic compounds can be converted into electricity or converted into methane. A traditional process to treat wastewater, recover energy, is called biogas. The major component of biogas is methane, CH4, the one you can use in the kitchen for cooking. So we can cover CH4 methane from wastewater treatment plant by microorganisms called methanogens. They are not bacteria. That's complicated. Or we can get bioelectricity directly using microbial fuel cell. First of all, how is wastewater treated? Any of you have any background about this? Any one of you have visited wastewater treatment plant? It's not very friendly smell, but it's not that bad. So we have a whole process called wastewater treatment. Now this is a schematic and not very good effect. So from here you have wastewater contain all kinds of things, even big chunks. So you have to filtrate them first. Otherwise you're gonna hurt the step next. So you filter them and let the heavy particle settle down. So you get some sludge. Now here the major component we call it biological wastewater treatment. So still the bacteria are really the good friend of us. They can do all kinds of amazing things. Here we just use some bacteria. We don't know exactly who they are, but they just there and they're working. They eat organics. They remove it. So the complete organic oxidation produce CO2, right? We can release CO2. Then we don't have to kick the organic into the river. So here we use the bacteria. Those two we use the bacteria to eat organics. You can imagine just eat. And there are different bacteria. Some bacteria, like human beings, would breathe oxygen, right? And some bacteria also breathe oxygen. We call them aerobic bacteria. So they eat organic, breathe oxygen, exactly like what we're doing. We eat organic bread, noodle, rice, they are organic, then we breathe oxygen and generate energy for our own. They're doing the same thing. Another group of bacteria, not really bacteria, we call archaea, also microorganisms called methanogens. They also eat bacteria. They also eat organic, but producing methane gas, CH4. So that's methanogens. So this is the schematic how wastewater is treated. So this is the traditional one. We produce methane, biogas. That's energy. And this is a biogas plant in Denmark. So please.
What is done with the wastewater?
What is the?
What is done with the wastewater?
You mean after the treatment? Well, for example, in the influence, you have a huge 1,000 gram per liter organic. After treatment, you probably only have 10. So you remove the majority of organic. Organic is waste. So that's what you have. Still, at effluent, it's not clean water. You cannot drink it. But it's much better than influent. So you can discharge them into the river. And there in the river still go through a slow treatment process because there's all kinds of bacteria in the river. So basically you just improve the water quality after this treatment process.
Do you prefer biogas fuel or hydrogen fuel?
Well, from sewage?
Like methanol or hydrogen?
Well, hydrogen is good. Hydrogen is good, but the storage will be a problem. Unless people really overcome that problem, hydrogen still has a long way to be real applied.
Do you think methanol can be used right now?
Methanol?
Yes.
You mean the methane or methanol?
Huh?
Methanol?
Yeah, methanol.
From where?
Well, because I mean, methanol is already used.
Uh-huh.
Speaker, and apparently it's already used, but can it be used on a large scale?
For transportation?
For powering houses.
Well, for houses,
Or any office building.
Uh,
Powering.
well, for the energy use, actually there are different purposes. For example, if you want to have the heat, of course California doesn't need, but in some very cold area you need heating. They don't really burn something. For example, when they generate the methane gas, CH4, they burn for electricity only 30% efficiency. 70% energy is lost. But it's really not really lost. You still generate a lot of a hot vapor. So people can transport those vapor as a heating, go to the local community for the heating. But for the electricity, that's another story. So they have to go to the combustion, thermal turbo process. So that's really depends. Let's say this. That's really depends on how you produce this energy. If you can produce the energy at a very cheap rate and large scale, it can definitely be used.
Do you think methanol could be produced on large scale and cheaply with the catalyst? It's produced from CO2.
Well, because I'm not really an expert on that,
Okay.
so sorry I cannot answer that. But for the methanol, but for the ethanol, now people already start using that, right? They add ethanol into the gasoline to make a mixture of the gas to save some gasoline because ethanol can be reproduced. The big issue is when you look at, still I said that before, when you use ethanol, you have to look back, see how ethanol is produced. This process consumes more energy than what you produce. that will be a different story. That's a long story. Okay. So currently the ethanol is used most because the government supports. So government gives the money to the producer because they don't make money. If you increase your ethanol price, nobody gonna buy the gasoline. They have to sell their ethanol at lower price, and government have to compensate some money to the producer. But that's not gonna be a sustainable way to make money because government is losing money. So this is a biogas plant in Denmark. In Europe, in Germany, Denmark, there are a lot of similar biogas plants. They're located in the center of farmland because there's a lot of farm waste, swine waste, cow manure, nasty stuff. Well, they are good things for the biogas plant. They produce huge amount of methane gas, and those gas are converted into electricity and converting to the heating to the local community. Actually, they make money from that, make profit. This is really not popular in America. I don't understand why, because this should be a really good technology. You generate energy, don't waste it. But now there are more and more biogas plants here built up in America. In Europe, they already built tons of that. They make profit from that. You reduce waste and make energy and make money. Why not? Okay, that's the traditional way for the methane. Now let's come back to the microbial fuel cell. So the structure and the process of a microbial fuel cell, we call MFC, microbial fuel cell, will be similar to a fuel cell. We have two components, anode, cathode. The different things for the fuel cell, remember, they are compact, small size. So basically two electrodes, just like two dimensions. Right? For the microbial fuel cell, we're treating wastewater. They have to be three-dimensional because you have a huge amount of sewage water, wastewater. So this is three-dimensional compartment, anode and cathode separated by a membrane. These are exact same as fuel cell. And we have electrodes, and we have bacteria. In the fuel cell, you use platinum as catalyst, right? You use platinum, very expensive thing. And in the microbial fuel cell, we use bacteria. That's the major difference between a microbial fuel cell and the fuel cell. The catalysts are different. So bacteria, we use bacteria as a biocatalyst. They eat organic fuel, make CO2. The other side, we can use oxygen, make water. And this little guy is what we call the electricity loading, whatever. So the electron goes through the electric loading, then they generate electricity current. Then we have hydrogen go through. So the whole process will be like this. Bacteria eat fuel, generate proton and electrons. And those things coming through the different way, but eventually they come to the cathode electrode, meet oxygen to make water. If we use glucose as example, so that's the whole reaction. One more glucose can produce 20 more electrons, theoretically. Alright, this is how microbial fuel cell is working. Since there's bacteria, we have to really look at how they look like, right? So this is a bacteria grow on the electrode. On the back, this is called SEM picture. It's really enlarged, like I remember 100 times or 200 times. So on the back is carbon fiber. In the MFC microbial fuel cell, we use carbon as the electrode. Well, you have to think about it, we use this technology for wastewater. We cannot use very expensive thing, right? For the fuel cell, it's okay. You can use very expensive platinum and best material to generate electricity. For the MFC, they're gonna dump into the wastewater. You cannot put very expensive stuff in. So we use very cheap carbon fiber. And this is we call pure culture. Pure culture means a single type of bacteria. They are the same one. See, they grow on the graphite, carbon graphite, and they just sit there, form biofuel. Whenever there's organic food pass by, they just grab it, eat, and give electrons to the graphite electrode. And in most cases, in reality, there won't be pure culture. Pure culture means a single type of bacteria. In reality, there are all kinds of contamination, right? There's all kinds of different bacteria. We cannot just use a single bacteria. So this is the mixed culture biofuel. See, we have this is a small magnification of the large real biofuel. And this is a cross. Outside you see the biofuel, and inside bacteria attached on the electrode. And they are the mixed culture. And we don't know who they are. So we have to use some technique to tell who they are. A simple technique we call the fish fluorescence in situ hybridization. It's a DNA staining technique. So basically, you put a different color attached to the different DNA. Similar group of bacteria will share a similar DNA. They're not identical, but similar. So we use the DNA to stain them. The green one is methanogens. That's the organism that is producing methane gas, CH4. And the red one, bacteria. And those are the bench reactors. So all kinds of microbial fuel cells. For the fuel cells, most 99% of fuel cells are same, which is narrow and stack. For the microbial fuel cell, we have all kinds of reactor configuration because we want to develop efficient configuration for wastewater treatment. So this is a traditional one, two-chamber. And this is upflow one. We feed the sewage water from bottom and get out from top. Oops. Okay. And this is called air castle, rotating sediments, whatever. There's all kinds of microbial fuel cells available. And these are the fuel cells I've been working with. So I've been working with very small, teeny tiny size to the very big size. So we need to make bigger and bigger MFC. Eventually, of course, we're not going to, for the wastewater treatment plant, they have the reactor 1 million gallons. I don't think we're going to make 1 million gallon reactors. The MFCs are special, but we really need to make this bigger to understand what's going on. So all those still at the research stage. They're not yet for the application. We're just starting, try to understand what's going on. Currently, we don't even understand how bacteria transfer electrons to electrons. You have to really understand this before you can improve your system. So these are really scientific research. And how much power MSC can produce? Not that much, but enough to power a fan. So that's a single microbial fuel cell power small fan. Not much electricity. Of course, people are always joking, are you going to just build a huge reactor to power a small fan above? Well, not really. You have to think about wastewater is a huge size. If you enlarge this to a huge size, the absolute power is still very good. Okay. All right. Now previously you see those reactors there for sewage. Actually, there's another type of microbial fuel cell, not for sewage. We can get energy from natural system, very simple. We just dump one electrode here into the sediments. You know, there's sediments in a river, lake, ocean. What are sediments? They're just soil, sands, bacteria, organic. Okay, we got bacteria and organic. Then they can make electricity, right? So there's a huge amount of organic and bacteria, all kinds of bacteria in the sediments. It's not that nasty, but pretty, yeah.
Oh, so are you gonna replace the platinum in cars?
Replace what?
Are you gonna replace the platinum in like hydrogen fueled cars?
No. That's what I'm saying. The microbial fuel cell are really different from fuel cell. Fuel cell, small size, huge power for the car vehicle. Microbial fuel cell, huge size, small power density for wastewater treatment. So they have totally different purpose. So we cannot mix them together. The fuel cell people always love us. Say, you guys only make such a teeny tiny electricity. Well, we have the different purpose. So, and for this sediments fuel cell, they're making even less energy. So what is used for that? You put 2 electrodes in a lake or in the ocean sediments. What can we do? Now think about this. There are a lot of remote wireless sensors nowadays put in a remote area. They're used to monitor the environmental parameter like temperature, humidity, all kinds of small, then they send those signals back. Those remote area means we don't go there often, right? Now currently they're using battery. And you have to think about that. Battery is cheap now, cheaper and cheaper. But every time when you need to go there to replace the battery, you need to probably rent a boat, have a couple of people. All those cost a lot, much more than battery. And if we can develop a sediments fuel cell, microbial fuel cell, they just stay there, theoretically forever. You don't have to make them very often. That saves a lot. So the process will be similar as a microbial fuel cell. Bacteria on the anode, in the sediments, there's a lot of bacteria. They just eat organic. And on the top, this is water, because there's water, in the water, oxygen is relatively higher than the sediments. So the water is reduced to the, oxygen is reduced to the water. they only make very, very teeny tiny electricity, like 10 milliwatt. 10 milliwatt. Usually we talk about electricity, we talk about kilowatt, right? Milliwatt is still like a watt. 1,000 milliwatt will be 1 watt, and 1,000 watt will be kilowatt. So they produce very little electricity. Well, those wireless sensors, they don't cost much. They probably use 50 milliwatt. They probably use 100 milliwatt, and they're not using electricity all the time. You don't need to know the temperature in the remote area every second, right? You only need to know probably every hour, every day. So they are using electricity in a very short period. Those sediments fuel cells are perfect for this purpose. So when they're not using the electricity, they just build up and store the small energy in a capacitor. So the capacitor can store the electric energy, small amount. And when those wire sensors need electricity, we just take it out for short-term burst. So this is probably one of the first example that microfuel cell can be applied in reality. Previously, I talked about sewage. We still have a long way to go to really put a microfuel cell into wastewater treatment plant. But this one already be applied. Still at research stage, but already be applied for a real-time evaluation. And then here at the USA, we're also doing the similar research. We put those verified electrode, here's the Long Beach Harbor. So we put those things into the sediments. They look like this. This is the cathode, and this is the anode in the sediments. It's really hard to take a good picture. You know, I didn't go there. They have the diver, so we have the cathode and the anode. It's hard to see anything, but they're in the sediments, and the depth is 4 to 5 meters. We're still testing it.
How much energy are those producing?
Well, we just put them in. We don't know yet. We expect them can produce like 10 milliwatt. You think about those electrode surface area. See, the same device. It's like 1 square meter, about 1 square meter total. It's a 6 piece, right? 7 or 6 piece. Total surface area is about 1 square meter. So if they produce 10 milliwatt, that's not really high compared to fuel cell. But 10 milliwatt, as I said before, probably enough to power some wireless sensor. And you just dump there, you can forever.
How long would it be able to last? Like,
Yeah, that's a good question. We said it could be there forever, but we never know, right? Because we cannot live forever. But as long as the people has tested for like 3 or 4 years, they're working pretty well. So within this range, that's good. For the batteries, 3 or 4 years, you have to replace a couple of times. You already spend more money than this one.
How much does it cost to manufacture?
Yeah, that's a good question too. This one, another good advantage about this is they're cheap. So we don't put a catalyst. The reason why fuel cell is expensive, one, because they use platinum. You know platinum is expensive. The second, they use the membrane we call net film, made by DuPont. It's an ion exchange membrane. This material is very expensive. For those type of devices, we don't need either of them. And that's also why they produce low power, because those things ensure you produce high power. So that's really depends on your purpose. Where are you going to apply them? And also, in our lab, we are looking at because those sediment fuels they're open to the sunshine. So there's always a photosynthetic process. So algae can produce organic. They produce hydrogen. They can also produce organic. So here, and we also have some aquatic plants. They're already there. So when you go to our lab, you won't see that. But we had them tested. They produce higher electricity than the one we saw because for those plants around their root area, they release organics, and there's a lot of bacteria living here, eating those organics. All right, I'm gonna wrap up. Take home notes. So I'm an environment engineer. I hope you can help us to provide our environment, protect. So the simplest way is to save energy in a natural source, such like water. At least don't waste energy. Use what you need. Do not waste the energy. So when you don't need light, you can just turn off. That's a very simple way. And any questions, or we can start work to our lab. Then we can discuss on the way. It's a short work. Okay. Major device configuration we use this float. And this is the traditional one, 2 chambers in front. It's simple. Yeah, you have two compartments. They're good for the basic study. When you want to study how bacteria transfer electron, whatever basic study, it's good. But they won't be able to produce high power because they're just not efficient. So later we figure out this type of reactor you see over there, here, they're same. We call upflow microbial fuel cell. The liquid goes through the inside. There will be granular carbon. So I don't have any example here. They're probably over the sink. So we have the big granular carbon. We use them as electrodes. Carbon fiber. So we use everything carbon. They're cheap. Carbon fiber, but they already coated with the nickel. So they have a better conductivity. Also, nickel has a little bit catalytic ability. It's not as great as platinum, but they're cheap. So we're environmental engineers, so we have to really use something cheap to treat wastewater. So this is the reactor. You see, we're doing experiment continuously. This one is we call batch. Batch means you give them food, wait. Then see current increase, drop, over, because they finish food. Then give them food again. That's called a batch experiment. And this one called continuous experiment. So we prepare the solution, artificial wastewater, with organic inside. And we use a pump to pump in slowly. So this is continuous. They can continuously generate electricity. This is simulating a real wastewater treatment. Because for the wastewater treatment plant, you cannot just, I treat wastewater today, I'm not happy tomorrow, so I stop service. And then the people around will be really mad. So you have to have a continuous operation. Yeah, please.
Oh, it was going to be about the whole operation. If water flow for some reason is disrupted and then like abruptly started all over again, so that it pushes, I guess, harder once it starts. How would it affect the whole thing of everything?
If I add the water just not continuously.
Huh?
What was your, sorry, what was your?
If you suddenly dumped a bunch of waste onto
See. Yeah.
Oh,
Of course, you will see that. We saw that clearly in our experiment. If you suddenly dump a lot of waste, they just, because they get a lot of food. Of course, they have capacity. Bacteria is almighty, but they cannot handle, when you give them more, right, above their ability, they cannot finish.
So what happens when it, like, you surpass their capacity? What happens then?
Well, you can inhibit their growth, inhibit their activity, but still, it's really hard to completely get rid of them. So you just eat too much hot dog or burger. You have to sit there, okay, digest for a while, then you recover. Bacteria will be similar. You give them food, they're happy. A lot of food, they're still happy. Too much food, they have to think about, wow, so many food, yeah. A little bit. But if you get really a lot of food, biology, inside that's really complicated process. It's not as simple as I said, just give them food. There's a biochemical reactions. If you give them a lot of food, they drop their pH in the water. pH is a very simple and important parameter for water. So they drop their pH. If you have a lot of food, the pH drop very low. Actually, they can kill the bacteria.